Hey guys, so today we'll be solving the second question in the Leetcode contest, weekly contest 355 that happened just yesterday. So let's get started. So this question is called largest element in an array after merge operations. So we're given an array and we're supposed to, an operation is defined in this way. We're supposed to choose an integer I from 0 to n minus 2, less than n minus 1, basically, such that nums of I less than equal to nums of I plus 1 holds. And we're supposed to replace the element nums of I plus 1 with nums of I plus nums of I plus 1 and delete nums of I from the array. So then we're supposed to return the largest element that we can after performing this operation any number of times. So since all the elements in this array are positive, it would be better if we can do this operation maximum number of times. So let's consider the example that they've given here, 23793. So consider 23793. We can choose any I. So let's choose I is equal to 0. This will be I is equal to 0 and I plus 1 is 1. So 2 and 3, if we compare, the condition holds that nums of I is less than equal to nums of I plus 1. So we need to do two things over here. First of all, we're supposed to replace nums of I plus 1 with nums of I plus nums of I plus 1, which will be 5. And we're supposed to delete 2. So after performing one operation, the array that we will get is 5, 7, 9, 3. Now, if we choose 5 and 7 over here, then the condition holds true. So, and if we perform the operation again, we get 12, 9, 3. Then if we choose this index and check between 12, 9, the condition does not hold true. So we cannot do anything. And between 9 and 3 also the condition does not hold true. So we cannot pick any index I such that we can perform the operation. So this is where we stop and say that 12 is the largest value we can find. But is that correct? No, it's not. Because here you can do something else. So we have 5, 7, 9, 3. So instead of performing the operation on 5, 7, we can do it for 7, 9. So after performing the operation, we get 5, 16, and 3. 5 is still less than 16, so we can choose an index. And we get 21 and 3. So we can now say that 21 is the largest element that we can get. So in this case, we perform the operation 2, 3, 4 times. So, so it is understood that, like if you consider this example, 5, 3, 3, it is more beneficial for us to add the 3 and 3 first to get a 5, 6, and then finally 11, instead of adding 5 and 3 to get 8, 3, and then stop this operation. So we want to perform this operation maximum number of times. Why? Because all of the elements are positive. So any addition will not do any harm. Any addition will just make it the largest. So that's how we're going in the direction of optimizing and getting the largest element possible. So how do we make sure that we do it the maximum number of times? It's simple. We just check and perform these operations from the end. Instead of choosing them randomly, we start from the end. So that we're making sure that, for example, if there are multiple positions in the array, and currently we're comparing this and this, we will want to make sure that this element is the largest possible. If this element is the largest possible and we're comparing with this, right? Largest possible by making use of all the operations that we can in this direction. And if this element is, we're checking if this is element A and element B. If A is less than equal to B, holds or not. If we're making sure that B is the largest possible, we're making sure that this condition will always hold, right? And if it doesn't, that means that we cannot perform any of these operations on the array anymore. And with that, if you just understand this simple thing that we want to perform this operation the maximum number of times, and we want that we should do it from this direction to make sure that our right side element that we're comparing with is the largest possible, that we make sure that it's the largest possible, then the code is fairly simple. So we can just see over here, I'm saying that n is length of nums, and I'm starting from the ending. So I'm starting from n minus 2 element, and I'm going up until the first 0th element, and I'm doing it with step size -1. So first of all, I'm checking if the condition nums of I less than equal to nums of I plus 1 holds. And if it does, I am updating the value of nums of I to be nums of I plus 1. So there's a small change over here. So I could update the value of nums of I plus 1 to be nums of I plus nums of I plus 1, like this side, right? But then I'm updating it to be nums of I because the next time I'm going to be comparing these two values instead. So if I'm deleting it anyway, I'm just making sure that it is at the right position instead of deleting it, because deleting would be an O of n operation, and inside the nested loop, it would make it O of n square. So I'll just explain this in a better way. So if suppose I have 4, 5, 7, and I am currently comparing 7 and 5 over here. So 5 less than equal to 7, we can perform this operation. So what I am doing is I am replacing nums of I with 7 and letting nums of I with 12 and letting this be. It's as simple as that. So what we should actually get according to the question is 4 and 12. What we're getting by just replacing nums of I with nums of I plus nums of I plus 1 is 12. In either way, if you delete, the next comparison would be this. Even if you don't delete and do it in this particular, if you update nums of I to be nums of I plus nums of I plus 1, the comparison would still be the same. So this is an optimization that we can do instead of deleting the element. So once we update that, we're returning the maximum like they asked. So that's it. That's a fairly simple code. Just the thought process of this is a bit difficult. So I hope my explanation helped. Thanks for watching.